Hello guys, once again. This will be the last video under chapter 2. This is just a summary, but for some reason, I guess I can say I was lazy to look for it, but I didn't find, in the papers that I checked, I didn't find word problems, so it will be the only thing we'll not be doing. Yep, but yeah, we'll do many of these questions in the future. I also plan to do like I'll just do a session where I'm just answering a particular question paper, going from the first question up until the last question. So yeah, all I want to say is that don't worry if a question covering a particular topic or subtopic is not in the summary questions we're gonna do. Don't worry about it, we're still gonna have a chance. And also I want to say, if you have any questions you'd like me to do or anything you'd like me to explain much further, just shout out, and yeah, you'll be good. So here we are solving for x, which this one is gonna be a no-brainer. So I'll make an assumption and say you have practiced factorizing a lot. So you would know that in the first question, I'll just say number 1, in the first question, x squared plus x minus 12. The easiest way to factorize this is to, since the coefficient here is 1, you just open your two brackets, equals to 0. You have your x, you have your x. You ask yourself a simple question. You take the number 12, right? This number 12, if you find its factors, which two numbers will give you 12 when you multiply them, and they will give you plus 1, they will give you a positive 1. If you add or subtract them, you would see the number is plus 4 and minus 3. From there on, you have x plus 4 equals to 0, or x minus 3 equals to 0. You have x equals to 3, x equals to minus 4. And then you are done solving the problem above. Maybe let's give it a try and test it out. You have minus 4 squared, minus 4 minus 12, and we get 0. We substitute, so we put on 3, and that'll be plus 3, we still get 0. Done and dusted, right? Going to number 2. Number 2 is a bit interesting because of that set that we see over there. Yeah, I mean, of course, this problem you can transpose, bring x minus 1 to the left hand side of the equation, but the issue is that it's gonna be a bit problematic. You will be able to solve this x, and you'll find the right x, I believe. The issue that I'm having is the difficulty of the problem once you transpose, right? That is why it will be just easier for you to first thing first, try to deal with this set by putting on the square root, and then from there we just continue. We know that the sets, they're gonna cancel out each other, so you have 2x plus 1, and you're gonna have x squared. So yeah, and then x times minus 1, that's minus x, times 2, that's minus 2x, and that will be positive 1. Then you can do the transposing, right? You have this, you have minus 2x plus 1, then it will be minus 2x minus 1, right? X squared minus 4x, and then the ones are going to cancel out each other because of different signs. So this is all that you will have. You still have your 0. You take out x, you have this, and you have, therefore, x is equals to what? X is equals to 0, or x minus 4 gives you 0, which then says x is equals to 4. You know what I'm saying? We can give it a try. We can give it a try and test it out. you have square root of 2 into 4 plus 1 equals to 4 minus 1. You're going to have a square root of 8 plus 1. You're going to have 3 square root of 9, which is 3, right? So everything works. The fourth problem is a bit interesting in a sense that it goes back to the previous chapter. It's 2 to the power of, let me just write it here and copy it. Right. So this is like the chapter we dealt with. The previous chapter we dealt with. Mohau, o senya video hle monna. So yeah, so this one, it's from the previous chapter. You already see your exponents, you already see your sets. So quite interesting problem. Let's get into it. First and first, you realize you have the same basis, so that means the exponents has to be the same. So you have x square root of x being what? Being 27, right? I can say this is just gonna be x to the power of 1 multiplied by x to the power of 1 over 2. Maybe let me just say this is what? This is 3 to the power of 3. I don't know how this is gonna help me, but maybe it might, maybe it won't. Let's just see. So laws of exponents, same basis, and we multiply, we add the exponents. That means we have x 1 plus 1 over 2, right? Yeah, and then I'm gonna have x to the power of 2 over 2 plus 1 over 2, 3 to the power of 3. That's x to the power of what? X to the power of 3 over 2 equals to 3 to the power of 3. Right, so now I want to eliminate that, exponent, so that I'm left with x, the easiest way I'm thinking would be raising to the power of 2 over 3. So what you do on the left, you also do on the right. So I'll have 2 over 3. So the idea is that this 2 will cancel out this 2, and this 3 will cancel out this 3. Eventually we just have what? We just have x to the power of 1, right? And on the side, this 3 is gonna cancel out this 3. We'll just have 3 squared, which is 9, right? So x has to be 9. We put it out into our calculator. 2 to the power of we'll say shift, I believe. Nah, not shift, bro. So what? We have 9 root 9. Damn. What? Is that for real, bro? Damn. Nah, that ain't right. That is not right. Damn. Good. Oh shit. Damn. So 3 squared is 9, right? Yeah. 3 squared is 9. So I have 9 square root of 9. Square root of 9. That is what? That is 9 multiplied by 3, which is 27. Yeah, which is 27. So which makes it 2 to the power 27, which is what we have there. Yeah, I don't know what I was doing with this calculator thing. Yeah, cool stuff. So I'm gonna erase this part to do the last one. The last one, nice and easy. This one is inequalities. Remember the thing that I said about inequalities? If you just have a straight up inequality like this, all you gotta do is assume that you are solving for x, right? Which technically you are. You're trying to find the value of x, which will make that statement 1.1.4 true. So first thing when you're solving for x, when you're at that level, it's just you factorizing. And since in this case we have the coefficient of x squared being 1, you just find, or you have x, then you find yourself two numbers, you multiply them, you get 8, you minus them, you get minus 2, that will be minus 4 plus 2, right? Yeah, and then you assume that you're solving for x, which you will find that x minus 4 equals to 0, or x plus 2 equals to 0. You have x equals to 4, x equals to minus 2, right? You do your number line with those arrows showing continuity, then you realize you have three regions, like we've been saying. You have three regions. So in the first region, I'm just gonna take any value below minus what? Any value below minus 2. I'm gonna have my brackets and say x. Say I go for minus 10, minus 4, and then on this bracket I have minus 10 plus 2, right? I'm getting a positive value, so I'm saying here I'm getting a positive value, right? So I go to the second region right there in the middle, any number in between. Easy one would be me taking a 0. If I take a 0, I'm getting a negative, saying that any number between minus 2 and 4 is gonna, if I substitute it on my equation, I'm gonna get what? A negative answer. Remember, we care about the sign, not the magnitude. All right, cool. Now any number greater than 4, let's just say 10, 10, I get a positive answer. Now I see this statement, it says less than 0, so we're looking for negative values, which happens between, between minus 2 and minus 2 and 4. And since they're not included because here on our inequality sign it's just less than, we don't have less than or equals to. So since this is not the case, you will have your circle which is not shaded, and you will have a line like that. And to write your answer, you'll just say x is gonna be between open bracket 2 and 4 close bracket, and then you are done. Whew. Let's see what the next question has for us. The next question, it says solve for x if f of x is equal to 0. So f of x, which is 5x squared plus 6x minus 7, you have that, and they say if it is equal to 0, you have 0, 5x squared plus 6x minus 7. So they say solve for x, if that is the case. So in this situation, you already see that the coefficient of a squared and the coefficient of x squared is not what? It's not 1. So let's go back to that method of mine where what do we do? Here's what we do. We take 5 and 7, we multiply them together. 5 multiplied by 7, I think is 35. I'll check. 5 times 7. Nice one. So 35. I'm writing the factors down. It's 1 and 35. 2 doesn't go in. 3 doesn't go in. 4, I believe not. So 5, yes. 5 and 7. 5 and 7, right? And then 6, it doesn't. We can even try it. 6 and then 7, it does. So now we're already back at 7. So it seems like 35 only have what? It only have these factors. You see, now it's a problem because we are having a hard time finding the numbers that if multiplied together we get 35. If added or subtracted we get a positive 6. We are having a hard time finding those numbers. Right. So now the question is, what do we do if you happen to be in this situation? Now this is that part where I will say, do you remember that thing that we dealt with called the quadratic equation? Or perhaps not the quadratic equation, because what you have here is the quadratic equation. The thing I want to talk about is the quadratic formula, ne? Yeah, so that quadratic formula, it's something like this. X is equals to minus b plus or minus square root of b squared minus 4ac, right? All divided by 2a, right? So you're just gonna take that. It's gonna be minus 6 plus or minus b squared 6 squared minus 4 into 5 into minus 7 and divided by 2 into 5. You end up having what? Minus 6 plus or minus, let me just take the calculator. That'll be 6 squared, which is 36, minus 4 times 5 times minus 7, right? I'm getting 176 by 10. Let me just see something. Square root of 176. Cool. So that's minus 6 plus or minus 4 square root of 11. And then I have what? I have 10. To simplify this, I can just say that's what? It's 2 minus 3 plus or minus 2 square root of 11. And that's 2 times 5, right? So in this case, the two are gonna cancel out each other, and you end up having what? You end up having minus 3 plus or minus 2 square root of 11 all over 5. That's your answer, ne? That's your answer. To be a bit fancy or a bit much clearer, you will say minus 3 plus 2 root 11 all over 5, or x2 equals to minus 3 minus 2 root 11 over 5. You're done. Yeah. Then you're done. You're gonna have, oh, they say correct to 2 decimal places. In that case, then you're done. You're not done. You're not done. You're just gonna go to your calculator. Minus 3 plus 2 root 11. That's 5 minus 7 to 773, I believe, because they said 2 decimal place. Go there, change into minus, we get minus 1.93. Then you are done. Then you are done. So on this question they say, hence otherwise calculate the value of d, right? Calculate the value of d. That will make this thing to have equal roots. Yeah, now that's when you remember equal roots, the discriminant, the nature of roots, right? So remember, for you to have equal roots, what must happen? Your discriminant, which is this symbol, it must be equals to 0. So b squared minus 4ac, which is your discriminant, it has to be what? It has to be 0. You go to this equation, I'll write it down. 5x squared plus 6x minus d. Copy that, go down, paste. Yeah, that equation. So on that equation, you already do your thing. Just use substituting your b. It's gonna be 6 squared minus 4, and then a is 5, and then a is 5, c is d. Let me see. Damn, bro, why are you stuck? Okay, it's minus d. So we're just gonna substitute it as minus d. Minus d equals to 0. You have 36 minus 20. That will be plus 20. Plus 20. 20d equals to 0. Saying 20d equals to 36. Divide by 20 both sides, so you have 20d divided by 20 equals to 36. Divide by 20, then d equals to 36 by 36 divided by 20, which is 9 over 5. Right, so that's the value of d. D has to be 9 over 5. And then, yeah, you're done solving this problem. Let us go into the next one. So actually this one, fortunately, this is the last example we're gonna do, and then we'll be done with this video. It's like 6 marks, and the whole thing, all the questions we have been doing so far until the last one, this one, they sum a total of 28 marks. So just be careful not to do any mistakes. Right, this is equation 1 and this is equation 2, ne? And here you already see on my equation 1 I can say x is equals to 2y minus 3. Call this maybe equation 3. And then if I'm using substitution method, substitute equation 3 into equation 2. So that means I have x, y equals to 20. That means I'm gonna have 2y minus 3, y equals to 20. I have 2y squared minus 3y minus 20 equals to 0. Here it's me factorizing, since the coefficient is not 1 and 3 is not divisible by 2. I'm just going to use my method. Multiply 2 by 20. That gives me 40. Factors of 40, that's 1 and 40. Remember, I'm looking for factors that will give me this number when I add or subtract. I have 2 and 20. I don't have 3, I have 4. 4 I believe is 10. I have 5, and I think 5 and 8. And fortunately 5 and 8, if I add or subtract them, I can get minus 3. Right, so minus 8 plus 5, it's minus 3. So cool. Now I take my numbers. Let me continue with the red color. It's gonna be 2y squared. And I don't know if I did actually say this, but when you now put this number here, you want to make sure that you put them closer to the numbers they will be divisible, like with, for example, here if I say 5y minus 8y minus 20, I might be making my life a bit, I don't know, maybe let me just see what's gonna happen. Equals to 0. I just want to see what's gonna happen. So I take out the common factor. It's gonna be y here, and then here I'm gonna have 2y plus 5, and then, oh shit, I had to group that. Yeah, I had to group that, make it minus 8, 20, 0. So y 2y 5 minus, if I take out 4, I take out 4, then I have what here, it's gonna be 2y minus, it's gonna be 5. Oh shit, it actually works. Shit. Alright, forget what I was saying, it actually works. Then you have a common factor, 2y plus 5, y minus 4 equals to 0. And then you have 2y plus, equals to 0. y equals to minus 4. Then you have minus 5 over 2. So of which here, if you substitute back, remember x is equals to what? 2y minus 3, I believe. Is that so? Yes, that is so. So here for x, my x here is gonna be x 2 into 4 minus 3. Damn. X is equals to 2 to 4 minus 3. That's gonna be 8 minus 3. That's 5. And then I have this side. I'm gonna have 2 into minus 5 over 2 minus 3. The 2 gonna cancel out each other. I have minus 5 minus 3. That's minus 8. Right, then I'm done. So my x values, that's 5. And then I have 4. This side I have what? I have minus 8. I have 5 over 2, negative 5 over negative 2. So you are done solving. You are done solving this problem using the substitution method, right? So let me go back. Right here, when I was about to substitute, I was just saying something which I proved myself that I was wrong. So I was saying something like, if you can also put these numbers and group them like this: 2y squared minus 8y plus 5y minus 20 equals to 0, of which from here we can maybe say group them already, and you're gonna have a common factor this side of what? 2y. Then you have y minus 4, and then you can take out 5 this side, plus 5. Then you have y minus 4 again. Then you'll have a common factor of y minus 4. You'll have 2y plus 5. You know what I'm saying? Equals to 0, which is exactly the same thing that we had right here. It's exactly the same thing we have right here. You look at this and you look at this, they're exactly the same. So it looks like it doesn't really matter how you group them, but just try to be careful. It's better to be safe than sorry. Maybe let me see. If I were to try elimination method might not work. Perhaps it could work. You could make it work, right? You could make it work, but I wouldn't advise it. I wouldn't advise you doing the elimination method here. So it's just because of this product. If you had maybe xy plus some y or maybe some x, then I was gonna say, okay, we can try this thing of elimination and see what do we do from there on. Oh no, actually we can make it work. We can make elimination work. I think we can. Okay, I'm gonna use the elimination method. I'm gonna make use of elimination method. I'll have equation 1, which is what? 2y minus 3. This is equation 1. From equation 2, I can say what? X equals to 20 divided by y. Right? That is equation 2. This is gonna be fun. I'm gonna copy that and paste it here. Right, so now remember, I'm using elimination, so I'm just gonna say let me just say negative equation 1 plus equation 2. Right, so I'm gonna have negative x is equals to negative 2y plus 3. Then I'm adding that 2 x equals to 20 over y. Is that right? Yes, it is right. Now, if I do my math, that is gonna be 0, and I'm gonna have what? I'm gonna have minus 2y minus 21 over y. Alright, and if I try to work out this, here I have a denominator of 1, here I have a denominator of y. My denominator here is 1, so I can just multiply this by y over y. That means I'm gonna have 2y squared negative 2y squared over y minus 20 over y, which is doable. The answer is just gonna be what? It's gonna be minus 2y squared minus 20 over y, right? Then I have what? I have plus 3, ne? Of which, after doing this, look at my equation. It's 0 equals to minus 20 y squared minus 2y squared minus 20 plus 3, this all over y. Look at my equation. I have eliminated x, which is the whole idea behind the elimination method. You're trying to eliminate one variable so that you're left with one other variable to solve, so which is exactly what I have here, and of which here I can multiply the whole thing by y. After doing that, I'll have 0 minus 2y squared minus 20, then I'll have plus 3y. You transpose everything, you have 2y squared minus 3y plus 20 equals to 0. So you have this thing. This is what you end up with after using your elimination method, of which you know from here you're gonna have to factorize. You factorize, and then after factorizing you find your y. After finding your y, you can find your x. That's insane. You can find your x. This is insane. You factorize, you find your y. After you've found your y, then you can find your x, right? So what I'm gonna do, I'm gonna copy this equation, which you all saw how we got that equation. Come back here, and then maybe let me paste it somewhere here. Paste it, and perhaps I can color it with a different color so that it stands out. So look at this equation. I think I have to push it a bit up. So look at this equation right here. I have a minus 20 there and I have a plus 20 here. It looks like I messed up something here. Let me come and see. I actually did mess it up. Yeah, I messed it up big time, because here, remember here we was adding this thing, so here it should be a plus, not a minus. It should be a plus, not a minus, and therefore here it's gonna be a plus, and therefore here it's gonna be a plus, and then here it's gonna be a plus, and then here it's gonna be a minus. I knew that I messed it up, and then after correcting all of that, everything just looked the same. Whew, damn. Yeah, everything just looks the same. So then you, of course, this is your what? This is your minus, right? So now they all look the same. You will just do exactly what you did on this page to get your answers, right? So few things for me to say. It is very easy for one to sort of make mistakes while solving these problems. So please recheck your answers. That's why you don't want to waste time on difficult methods. You want to use those easiest, simplest methods to do your math and get to the answer as fast as you can, so that you'll have more time to recheck your answers. There's always kind of a higher possibility of you having made a mistake, and you might not even realize that you did make a mistake until your paper comes and it's not 100%. Do you know what I mean? Yeah, so good luck, all the best, and I'll see you in the next chapter.